Hello everybody, today I'm going to explain what is noise using augmented reality. Noise is a sound wave that is perceived harsh, unwanted, irritating, and annoying by the human ears. As far as physics is concerned, noise and sound are both the same thing because at the end of the day, they both are pressure fluctuations traveling through a medium like air. The difference arises when the brain receives these signals and perceives it. So this classifies noise as a subjective quantity. It varies from people to people. What is sound for some people may be categorized as noise for others. Let's see it with an example. Alright, here's a piano. Let's consider a melody track. So people who really like piano might classify this as pleasing sound. Alright, here's a drum kit. Let's consider a sample track. Alright, so if you make the same piano subjects to listen to this noise, they might classify this as pure noise because it sounds irritating for them. So this is a psychoacoustic problem. So this is a subjective problem where people classify something as noise and something as sound. Alright, although sound is subjective in nature, there are certain sounds that are perceived as pleasant by a vast majority of people, and at the same time there are certain sounds that are perceived as really annoying by a vast majority of people. There is a reason why it's perceived as pleasing and annoying by a vast majority of people. Physics is the reason. So let's play these sound files of pleasing and annoying, and let's study their time data and their frequency spectrum in detail. Alright, this is a trace of a melody that I played earlier. Let's play it again. Alright, now this is the trace, and let's study the frequency spectrum to understand why it is perceived as pleasing by a vast majority of people. Alright, this is a spectrograph of the piano note that I played earlier. So the y-axis is the amplitude and the x-axis represents the frequency in hertz. So if you study closely, around 300 hertz is the fundamental frequency, and there are lots of harmonics following that with decreasing amplitude. There are definitely even and odd harmonics. So the harmonics are the reason for the pleasing sound. The harmonics, they add they improve the timbre, the sound quality, by adding brightness to the sound. They make the sound more richer. Even a pure tone cannot sound really pleasing. It might be intimidating, but harmonics really improve the sound quality. Alright, a classic example of a noise signal that is perceived as really annoying by a vast majority of people is a jackhammer noise signal. So jackhammers are used to drill, like they are a pneumatic hammer drilling on asphalt or concrete. So they are commonly used for roadworks. So this is how a jackhammer signal sounds like. Alright, so it's impulsive and repetitive, and this is what creates a feeling of annoyance for most humans. Now let's study their frequency spectrum to get more details. Alright, this is a spectrograph of the jackhammer noise signal that I played. So if you look closely at this graph, you cannot make out any fundamental frequency or harmonics. In fact, the entire frequency spectrum is present here, right from 20 hertz to 20 kilohertz. Because, it's impulsive in nature, it lasts for a very short duration, and in that duration, every single frequency is being played. So due to the lack of harmonics, it's a haphazard, mixture of different frequencies, and it creates a feeling of annoyance for humans. Alright, thank you for watching this video. I hope you enjoyed it. Have a great day.